Hello everyone, welcome to this video. In this video, we are going to study about builder pattern. This is one of the creational design patterns. So, we are going to study the builder pattern by building a pizza. That's why you are seeing this image on the screen. So, first of all, let's define the problem statement. Let's say you have a complex object to build. That object has many attributes and they need to be initialized. Let's say I'm taking this example. It's a pizza class. It has 4 attributes. For the sake of simplicity, I've taken all of them as string. But they can be user-defined data types also. So in this example, we have crust, sauce, cheese and toppings. Now, let's say I want to create a pizza. I would have to pass all 4 parameters to the constructor. Now what if I want to create a pizza with just cheese, sauce, crust and no toppings? What if some other user comes, that user wants to create a pizza with crust, sauce and toppings, no cheese? Some other user comes, that user says that I only want a simple pizza with crust and sauce. That's where the problem gets interesting. For the same class, we have to create different types of objects. They have different behaviors. So how do we solve this problem? Let's see. So the first solution which comes to mind is we can make use of inheritance. Let's make a base pizza class containing the basic properties what we had seen before. Now we will make a child class cheese pizza. It will contain cheese attribute. So if I override this behavior, now this cheese pizza class effectively contains crust, sauce and cheese. Let's make one more class, toppings pizza. This also will be the child class from the base pizza class. This will effectively contain crust, sauce and toppings. We'll create one more class which will contain all the attributes, crust, sauce, cheese and toppings. Now let's say if our number of attributes in the base class are increasing, we'll have to create multiple number of child classes and override them. For different permutations, combinations, there will be so many classes that we'll have to create. This doesn't seem like a viable solution. Okay, now let's see one more approach where we can solve this problem. Second solution is create multiple constructors for each combination. For example, this is a default constructor. Make a constructor for crust and sauce. Similarly, make a constructor for crust, sauce and cheese. Similarly, make one giant constructor with all the attributes. Now this also doesn't seem like this will solve the problem. But again, if there are more number of attributes, our class pizza will be filled up of a lot of constructors only. Some having one attribute, some having not that attribute. So it will become a lot of bulky. So this also does solve the problem, but it's not exactly a viable solution for us. So that's where builder pattern comes into the picture. Builder pattern is a design pattern that is used to construct complex objects step by step. Builder pattern separates the construction of complex object from its representation, allowing the same construction process to create various representations. And object construction is delegated to builders. Now, there are various components, building blocks on the builder pattern. Let's study them. There are 4 components. First is the product. Product means the actual object that we want to build. In our case, it is pizza. Pizza class, we want to create an object of pizza. That is the product for us. Now, builder. Builder can be an interface or an abstract class that defines the contract, how to build the product. Third is concrete builder. Concrete builder means the implementer of this builder. From the name itself, it is clear that it is the implementation of the builder class. Fourth is director. Director means the class that constructs the object using the builder interface. Now let's see this in action. This is the project I have created, design patterns. Every code that I'll be writing, I'll mention the GitHub links into the description. So I'm going to create a class. First, create a product. Product for us is pizza. So we'll create a pizza class. Private string crust, private string sauce, string cheese, string toppings. Now let's create getters and setters for the same. Okay, getters and setters are created. Now this pizza class is completed. This is product for us. Now what do we have to create? We'll have to create a builder. So let's create an interface. I choose interface, builder. Now here I will specify the contract, what all things it needs to build. First I'll say build sauce, void build crust, void build cheese, void build toppings, and it will contain and it will give me an instance of pizza class, pizza object. So let's make a method get pizza. So whoever will call this get pizza method, they will get the pizza object. So I made this interface. Now let's implement this interface. Let's make a pizza builder. I will have to implement the interface. Doing so, it will give me some compile time error because I have not implemented the methods. So let's implement them. Okay. And I need to have an instance of the product. This product we are going to create and we are going to fill. Let's make a constructor of this class. Public pizza builder. Pizza is equal to new pizza. So this is a simple object of pizza class. It doesn't contain any attributes as of now. We have not initialized anything. Now let's do the initialization of various attributes present in the pizza class. First, pizza sauce. We'll say initialize it with tomato. Okay. Let's go for crust. What kind of crust do you want for pizza? So let's set thin crust. Okay. Cheese. What kind of cheese do we want? Let's set mozzarella cheese. Okay. Toppings. What do we want to set for toppings? Let's add tomato and basil. And this is a very simple implementation of the builder. As per the business use case, it can be more complex also. This is just to demonstrate how to create builders for our product. Now our builder also is created. Now we have to create a director. let's create a director for us. So let's make a class pizza director. Okay, so the job of director is to construct pizza using the builder. Okay, let's see how to make a director. First, we need a builder. So let's create a variable for builder and create a constructor for pizza director. Public pizza director. Inside the constructor, we will ask the invoker of this pizza director that, hey, provide me a builder first. I will build your pizza accordingly. Whatever builder you pass me, your pizza will be built accordingly. So I have the builder. Now this dot builder is builder. Okay. Now we need to construct the pizza. Let's see how to construct the pizza. Public void construct pizza. I have the builder. All I need to do is invoke the methods dot build crust, builder dot build sauce, builder dot build cheese, builder dot build toppings. Once the invoker of director calls construct pizza, our pizza object would be ready to be used. It is created. Okay, now only thing left is we need to return the pizza object. So public pizza will create a getter for it. And we need to return the pizza. But where is the pizza? The pizza that we just created, where is it? Let's go to build toppings. This is where the pizza is present. Okay, it's inside the builder. So only thing that is left is return builder dot get pizza. Done. Pizza director is also ready for us. Now we need to get the actual object. How to invoke everything and get the pizza. How to bind everything together. So let's see how the invocation happens. So let me create a class. I'll call this build me pizza. Okay. Now I'll have to create a main method. And I will create pizza builder. Now, why do I need pizza builder? I just need to invoke pizza director because the director contains the construct pizza method which I need to pass. But the pizza director also needs a builder. When we create an instance of pizza director, we need to pass the builder. That is why we need to create a builder also for us. So we'll go here, create a pizza builder, new pizza builder. Now let's make a pizza director. Pizza on director. Director is new pizza director, and we will pass the instance of pizza builder. Director is also happy. Now we just need to call dot construct pizza. It will make the pizza ready. We just have to get the pizza for us. We'll call director dot get pizza. And here you go. We have the pizza object ready for us to consume. Now there is one more way where we can create the pizza object without a director. We can use a builder pattern without using a director also. Director is often used to encapsulate the construction process and ensure a specific sequence of steps are followed for constructing an object. But it is not mandatory to have a director. Instead, you can delegate this responsibility to client code also if they want a better control over their construction steps. This approach can be helpful when the construction steps are straightforward or when the client needs more control over the process. Let's see how this can be done. Now this is alternate step. So I'll create a pizza builder. My custom builder is equal to new pizza builder. Okay. Now I will invoke this my custom builder and I will say build trust. I will say my custom builder dot build source. Okay. I will say my custom builder dot I don't want cheese. I just need some toppings. Don't add cheese. So build toppings, not adding cheese. So how will I get my pizza with this approach without using a director? I'll say my custom pizza is equal to my custom builder dot get pizza, and this pizza object does not contain any cheese. So this step that we did, you can also say these are the manual steps. We are not using a director, but we are delegating the responsibility of object construction to the client. Now let's see the advantages of this builder pattern. First is customization. We can create any number of builders to create number of different variants of pizza for us. Veg pizza, non-pizza, or we can delegate the responsibility that to the client. Let's say you want to create a custom pizza for yourself. You take the builder, you build it. However way you want, however way you see fit, you build the pizza for yourself. So, lot of customization options are available. Second thing is flexibility. It allows for various representations of the pizza based on customer preferences. And the third advantage is single responsibility principle. So we have isolated the complex construction process from the pizza class to the pizza builder class. So pizza is a simple pojo. It just has the attributes, and the construction logic resides inside the pizza builder. Now, what are the disadvantages? The disadvantages are it creates some code complexity because we are creating more number of classes. We have made a pizza builder, we made a director. So this is the disadvantage of this approach. Now, usage of builder patterns. I'm sure many of you would have used string builder or string buffer. They have append method. So append method is also following the builder pattern approach. We invoke append method multiple times, pass the string, and it appends the string to a pre-existing value. So that all thing happens using a string builder or string buffer using a builder pattern approach. So I hope this video would make sense to all of you who are preparing for interviews or who are just curious to know about builder patterns. How to implement it, the whole example that I showed you, I will be sharing it into the description. Please follow for more.